Hello, space lovers. When we talk about the search for extraterrestrial life, our eyes and our telescopes are almost instinctively drawn to the light. We look for the glimmer of distant stars and the planets that orbit them. We have become obsessed with a concept known as the habitable zone, or the Goldilocks zone. We tell ourselves that for life to exist, a planet must be positioned just right, not too close to its star to be scorched, and not too far away to be frozen. It needs to be in that perfect, narrow band where water can exist as a liquid. This has been the guiding principle of astronomy for decades. But what if we've been looking in the wrong place? What if our obsession with starlight has blinded us to the possibilities hiding in the dark? Recent research and a shift in scientific thinking are tearing down our old assumptions. We are now facing a radical possibility that the creation of life might not require a star at all. In the vast, infinite stretches of the universe, in the pitch-black void where no sun ever rises, there are lonely planets and hidden moons that might be teeming with alien life. Today, we are going to journey into the dark to uncover the mystery of exomoons and the terrifyingly beautiful concept of rogue planets. To understand the scale of this potential, we have to look at our own backyard. In our solar system alone, orbiting our humble family of planets, there are over 400 moons. Think about that ratio. If our single star system has hundreds of moons, imagine the sheer number of moons orbiting the billions of exoplanets across the Milky Way galaxy. These are what we call exomoons. Logically speaking, these moons should vastly outnumber the planets themselves. The universe should be absolutely cluttered with them. But here lies a frustrating paradox. Over the last few decades, humanity has achieved the incredible feat of confirming thousands of exoplanets. We have found gas giants, super-Earths, and lava worlds. Yet, despite these triumphs, we have not officially, definitively confirmed the existence of a single exomoon. Not one. Why are they hiding from us? The answer comes down to the limitations of our current technology and the sheer scale of the cosmos. To find a planet, we typically use something called the transit method. We stare at a distant star and wait for a planet to pass in front of it, blocking a tiny fraction of the star's light. That dip in brightness tells us, hey, there's a planet here. Now, imagine trying to spot a moon orbiting that planet. The dip in light caused by a moon is infinitesimally small. It is a whisper of a signal buried in a roar of cosmic noise. Often, the natural variability of the star itself, or electronic noise in our instruments, masks these tiny signals, leaving scientists debating whether they are seeing a moon or just a glitch in the data. There have been tantalizing clues. We looked at data from the Kepler Space Telescope regarding planets like Kepler 1625b and Kepler 1708b. Scientists thought they saw the signature of massive moons orbiting these worlds. But the scientific community is still divided. Debates are raging right now. Some researchers are convinced the moons are there, others argue it's just data error. So as of today, the trophy case for confirmed exomoons remains empty. However, we are getting smarter. Instead of just looking for shadows, we are starting to look for chemical fingerprints. Take the gas giant WASP-49b, for example. Astronomers detected massive clouds of sodium and potassium gas surrounding this planet. Now, strictly speaking, those gases shouldn't be hanging around that planet in those quantities. The best explanation? A volcanic moon, violently erupting and spewing these elements into space, much like Jupiter's moon Io does in our own solar system. And then there is the game changer. The James Webb Space Telescope. This masterpiece of engineering recently turned its golden mirrors toward a young, massive object named CT Chameleontis b, located about 620 light-years away. This isn't just a planet, it's a world still in its infancy, surrounded by a swirling circumplanetary disk, the very nursery where moons are born. When James Webb analyzed this disk, it found something that shocked the astronomers. The disk is rich in carbon-based chemicals, things like acetylene and benzene. But here's the twist. The star that this planet orbits is surrounded by gas rich in oxygen. So the star has oxygen, but the planet's moon-forming disk is full of carbon. This tells us that the formation of moons is far more complex than we thought. It suggests that out there, we might not just find water-rich moons like we see in our solar system, but exotic, carbon-rich worlds with chemistry completely alien to our understanding. But let's take a step further into the darkness. Let's leave the stars behind entirely. We need to talk about rogue planets. We tend to assume that every planet belongs to a star, tethered by gravity in a perpetual orbit. But the universe is a chaotic place. When solar systems are first forming, it's a violent game of gravitational billiards. Planets jostle for position, and in the chaos, some are kicked out. They are ejected from their homes, cast out into the freezing interstellar void to drift alone forever. These are the orphans of the galaxy, and they are not rare. Scientists estimate that in our Milky Way galaxy alone, rogue planets might outnumber stars by 10 to 1. Think about that number. We are not talking about millions. We are talking about trillions of these lonely worlds wandering in the dark. Now, your instinct might tell you that a planet without a sun must be a dead, frozen wasteland. How could life possibly exist without the warmth of a star? Here is the plot twist. When these rogue planets get kicked out of their solar systems, they don't always leave alone. Simulations suggest that they likely drag their moons along with them into the darkness, and this journey changes everything. The orbit of the moon often becomes destabilized. It gets pushed into a tight, elliptical, egg-shaped path. This is where physics performs a miracle called tidal heating. Imagine taking a rubber band and stretching it, then relaxing it over and over again, hundreds of times a minute. What happens? The rubber band gets hot. This is exactly what happens to these moons. The massive gravity of the rogue planet stretches and squeezes the moon as it orbits. This constant friction generates immense heat inside the moon's core. So, while the surface of the moon might be covered in a shell of ice thick enough to withstand the vacuum of space, underneath that ice, the core is hot. That heat can melt the ice from the bottom up, creating vast, global oceans of liquid water that can last for billions of years. No sun required, no light required, just gravity and friction. A recent study suggests that around 12% to 15% of the moons orbiting these rogue planets could experience this kind of tidal heating. If you apply that percentage to the trillions of rogue planets out there, the math becomes staggering. There could be hundreds of millions of moons in our galaxy right now that have dark, warm oceans teeming with potential. But can life exist there? Absolutely. We have proof right here on Earth. Deep at the bottom of our own oceans, where sunlight never reaches, life thrives. Entire ecosystems exist around hydrothermal vents, feeding not on photosynthesis from the sun, but on chemosynthesis, chemical energy from the Earth's interior. If it happened here, why couldn't it happen on a rogue moon drifting through the interstellar void? The James Webb Telescope has even spotted objects that blur the line between planet and star. These are called free-floating planetary mass objects. They are giants, 5 to 10 times the mass of Jupiter. They are so big that they can form their own miniature solar systems. Webb found these objects surrounded by disks containing silicates, essentially sand and rock. This is the raw material for building rocky moons or even Earth-like planets. So you could have a system where a massive gas giant acts like a star, without the light, orbited by rocky, Earth-sized moons. It is a mini solar system drifting through the dark. This isn't science fiction anymore. We are moving from theory to detection. With tools like James Webb and the upcoming Giant Magellan Telescope or the Habitable Worlds Observatory, we are on the verge of analyzing the atmospheres of these distant worlds. But perhaps the most exciting search is happening closer to home. We are about to launch missions like the Europa Clipper and Dragonfly to explore the moons of Jupiter and Saturn. If we find even a single microbe swimming in the dark oceans of Europa or Enceladus, it changes everything. It proves that life doesn't need a Goldilocks zone. It proves that life is stubborn and can thrive in the dark. The universe is not just the points of light we see. The empty spaces between the stars are not empty at all. They are filled with silent, invisible worlds. There are likely more planets in the dark than there are in the light. In those dark oceans, beneath miles of ice, there could be complex alien ecosystems. They wouldn't know what a star is. They wouldn't know what a galaxy is, but they would be alive. It's a chilling but beautiful thought. Maybe the aliens aren't looking at us from the stars. Maybe they are drifting in the dark, watching from the shadows. What do you think? Could the most common form of life in the universe be hiding in the dark? Let me know your theories in the comments below. And if you want to keep exploring the mysteries of the cosmos with us, make sure to hit that like button and subscribe for more updates from the deep universe.